I'll begin with a word of prayer. Most everybody who's here is here. That much is safe to say, I think. So, Heavenly Father, we thank you for this day. I thank you for the students. Pray you help us to use this time wisely, just to review for the test tomorrow. Just pray that you'd give the students the calmness to study wisely. Make sure they get enough rest tonight, Lord. In your name I pray. Amen. Of course, it is fairly late in the day, so I don't know. So, questions? You guys have questions? Yes, sir. You say parameterizations, how to do those? I mean, I can't really go over, like I've said before, there's no way I can hope to show you every possible parameterization I might ask you on test. What I can tell you is you should have read the notes, and you should have done the homework problems, and if you can do problems like those, you should be okay. Is there a more specific question you have? I mean, like, how can I do parameterizations is too general a question for me. The one that's on the practice test? Now that I can do. You mean the one from last year? Yeah. Let's see here. If I can find that, that'll be a good one. I mean, again, there's some themes I can tell you. I mean, a lot of times the converse sine squared plus cosine squared or cos squared minus sin squared being 1, that's helpful. If you can view what you're looking at as one of the coordinates of the spherical or the cylindrical coordinates frozen, the other two being variables, sometimes that gives you a parameterization, right? But generically speaking, there's lots and lots of things that can happen, and you know, I mean, I can tell you the generic setup. Was it test 1 from last year we're talking about, or? Do you happen to remember which problem? 7, all right. But, I mean, I will say this. I mean, so it also depends on how the problem's given to you, right? If you're given the thing is a level surface, so you're given f of x, y, z equals to some constant, right? Then your goal in the parameterization is to basically find, you know, x as some function of u and v, y as some function of u and v, z as some function of u and v, such that what? Such that when you plug those in, what happens? You get the constant, whatever it is, right? So generically speaking, that's what you're trying to do. You're trying to find formulas in terms of the parameters such that it satisfies the defining condition for your surface. So this one here, you got what? Our z squared equals x squared plus y squared. So let's see here. I look at this, and I have two thoughts. The one thought is, well, this is really z squared is equal to r squared, right? In cylindrical coordinates. So I could look at this as simply z is equal to plus or minus r, right? And so one nice parameterization I could give would just be this. I could use, let's see here, I guess I'll use r vector. And what am I going to use for my parameters? What's that? T and theta. T and theta? Oh, okay. I'll take it. Now, so we have x is equal to r cosine theta. We have y is equal to r sine theta. And we have z is equal to z for cylindrical coordinates. Now, if I use his advice and use t and theta for my parameters, I'm going to let theta actually be the theta of the cylindrical coordinates in my formulas. And I'm just going to put z equals to r, basically. So basically, that suggests I let t be z, essentially, right? So I would do t cosine theta, t sine theta, and then t. That's the top of the cone. But And this is kind of funny. If I just let t go negative, it'll also get the bottom of the cone. But, so I mean, that would work. If you think about it for t in the reals and 0 less than or equal to theta less than or equal to 2 pi. Although I would comment that when t is negative, theta doesn't have its usual meaning because that's essentially like a negative radius. So, but anyway, it's still a parameterization. How do I know it's a parameterization? How do you check? If I said this is a parameterization of one of these three surfaces, which one is it? How would you check? If I gave you three options, right? Suppose I told you this is a parameterization of some surface, and then I gave you some options. I gave you it's x squared plus y squared plus z squared equals to 1. Or I said it's x squared plus y squared equals to z squared. Or I said it's x plus y plus z equals to 3. I said which this is a parameterization of which surface? How would you figure out which one?
Plug it into each equation and see which one equals out.
Exactly. I would soften your advice by saying think about plugging it into each one of the equations, because if I actually wrote that all out, my test time would be over, right? But kind of, this is kind of stupid because you already know which one it's going to work, but hypothetically you could ask a question like that. So x squared, x is equal to what? X is t cosine theta, y is equal to t sine theta, and if you calculate x squared plus y squared, what do you get? You get t squared cosine squared theta plus t squared sine squared theta, which just collapses back down to t squared, which is equal to what? Which is equal to z squared, right? So, it works. Yeah.
You did a parameterization example with a hyperboloid where it was x squared plus y squared minus z squared equals 1. But what if it was x squared minus y squared plus z squared equals 1? We were trying to figure that out.
This one?
Yeah, we were a little lost.
Sure. I would let x equals to cosine theta cosh, let's say t. I would let y equals to sine theta cosh t, and I would let, z, rather not y, z. And I would let y equals to sinh t. That'd do it. Yeah.
Okay, so if I was looking at that x squared minus y squared plus z squared, how would you define the thing with cosine theta cosh t? Like, why would your brain go to that?
Because I did the other example that's like it. That's why I did it. But why, again, my brain, I think about this and this collectively as becoming the cosh squared. And I know, because I know cosh squared minus sinh squared is the thing I need overall. But I know that I can take two things which are added together as squares, and I can make them become one thing by attaching a cosine to one and a sine to the other. So that's why I put cosine and sine with the cosh, and I put the other with the sinh. But the more honest answer is because I did the other example, which is just like it.
It looked like on this test right here, that you had written out solutions. You didn't finish the solution for the last problem.
Oh. I can look at that. I don't know. I do not remember. It's been a while since I didn't write or wrote something. Oh, so guys, when you look at the solution, I think it's maybe even clearer for problem 7, because I put t there because he told me to, but I'd rather put a z there because it reveals what it really is. I'm using z and theta as the parameters for that example, but it's the cone. So you just use z and theta to parameterize. They will serve as good. I could have used r. I could use z or z or r pretty much appear symmetrically here. I could choose either one of them as the parameter. it's not, either one would work. Okay, the last problem you asked me about? Problem 15. Oh, so A and C are non-zero, non-collinear vectors, and gamma is a curve, parameterized like so. F and G are smooth functions, which means I can differentiate to my heart's content, and are not the constant vector. Find the torsion. So what was you just want? What are you? What's your? I'm not sure what your.
I'm trying to see where the torsion is. Maybe I missed it, but I didn't see it there.
Anybody care to tell me what's the answer? What's? I mean, I haven't told you too much about theory of curves. One of the things I shared with you is that torsion is 0 for a planar curve. If a curve lies in the plane, we can talk about this geometrically. Can I erase this? Again, my best advice for you in terms of how to parameterize things is to read my notes, to do the homework, and think about what I did. There's no, here's an algorithm. Remember these 3 steps. Do this first, then that second. I mean, it's like graphing functions. There are some general rules, but so if it's a planar curve, there's some plane in which the curve lies, right? I don't care what the curve looks like. The boring thing about a planar curve is that wherever you look at the tangent and the normal, right? No matter what they look like, the tangent and the normal, they're always in the same plane. So like T of t and N of t lie tangent to the plane P at all t, right? That's what it means for a curve to be planar. What does that say about the binormal?
It's always normal to the
Yes, right. But binormal is, so basically B of t, so say again what? Right, it's in the same direction as the normal to the plane, right? But that means it's constant though, right? Because the binormal has length 1. So basically the binormal just kind of, I mean, if this plane was the board, the binormal it's moving, it's attached to different points, but it's always just the same direction. The binormal is constant, is my point, for a planar curve. It's attached at different points, right? But its vector direction is the same. So this is constant. It's just some constant vector. And so what's that say about B prime? Yeah, dBdt is equal to 0, but that's also equal to minus the torsion times the normal. But the normal's non-zero. Therefore, the torsion must be 0, right? So my observation about this curve would be that there's no way it can pick up any kind of element except in the A and the C directions, right? So my observation for this formula is that it lies in the plane which has the vectors A and C as tangent. So this is a planar curve, so its torsion is 0. Now, you could also calculate that by calculating the unit tangent, calculating the normal, taking the cross product, differentiating, and see it's 0 as a consequence of the formulas. You could work that out. Is another way. But it's far easier to think conceptually here. Yeah.
How did we determine that it was a planar curve, though? Is that because of the A, C, again?
Well, look at its formula. A and C are constant vectors, right? So it's going in the A direction or it's going in the C direction. I mean, they're not collinear, but there's just 2 vectors, right? It can't pick up any time dependence in any other direction except for the A and C direction. You're just adding multiples of A and C in that formula. There's no third direction there.
Sorry, you said A and C are constant?
A and C are constant. Of course, the functions f and g are not. So it could be some kind of crazy looking curve like my picture. But the point is, it only can be developed. It's only developed in this is A direction and the C direction if you look at it geometrically.
But if there had been like plus an vector, then
Yeah, then I
there's no line torsion.
right. Then I wouldn't ask the question then. Yeah. Or I would ask it in a different way, which made it not ridiculous. I mean, this is a challenge question, obviously, right? That's why it's at the end. As do not punish the students. Right, I wouldn't put this first. That would be nasty. What's the first question on the test? Those are easier, right? Yeah. I mean, I guess if I didn't like a class, maybe I'd put that as the first question. But no. So, other questions? What would it mean for the curvature to be constant? Yeah, it's part of a circle. You can prove that. We have not, but you could. Yes, sir.
So on the quiz, where you have PQ on,
Talking about the quiz of the same, right? This one? You want me to look at the solution or the statement of the problem?
the solution.
Okay.
So, 7 you had a parameterized points, which I did fine, and then for 8, just use the Cartesian equation of the plane,
Yeah.
saying those points, which, like, I understood why you had the A vector as P, with the PQ vector, and then the PR vector as B, but I didn't understand why it was B cross A.
Well, what is the Cartesian equation to a plane? How do you find the Cartesian equation to a plane? If I have a plane, like so, right, and I have a point on the plane, let's say x naught, y naught, z naught, and I know that my normal vector n is, let's say, ABC. What's the equation for the plane? It's A times x minus x naught plus B times y minus y naught plus C times z minus z naught equals to 0. That's the Cartesian equation for that plane. So in order to find the Cartesian equation for a plane, I need the what? I need the normal. So how do I get a normal? Well, if I have two vectors in the plane, right, if I have a vector A and if I have a vector B, and if they're tangent to the plane, then A cross B gives me a vector which is in the normal direction.
Then does it matter if it's normal or binormal?
What do you mean binormal? Binormal is,
The opposite direction of the normal vector, so B cross A.
so your question is, how do I know which one's A and which one's B,
I guess.
essentially? The answer is it doesn't matter. So if I do B cross A instead of A cross B, what happens? And so all I end up doing is I multiply the equation by -1.
Okay.
So it's the same equation.
Okay. So if it
Don't worry.
Yeah.
If you have minus the equation, I will not be confused. I will still give you credit. I can see past these differences when I grade. Don't worry. You can't go wrong. As long as you do something like that.
And then for the Cartesian equation, like use P like 2, 0, 3. Does that matter?
Again, you can choose whichever base point you want.
Okay.
You'll get the same equation. It just amounts to like adding a constant to both sides. If you want some unambiguous, like if I wanted to make the Cartesian equation for the plane unambiguous, I could do something like ax plus by plus cz equals to d, and then I guess I could make some convention that I force a to equal 1 or something if possible. That would give me a unique equation. But I don't do that because that would be annoying, and there's no point. So There's just an ambiguity. I mean, there's lots of different equations which give you the same plane. Yep.
Kind of a similar question, but this is for the parallel pipette. How do I know which vectors A, B, and C? Because it's A dot B, C dot
Ah.
B, no, A dot B cross C.
So the volume of a parallel pipette spanned by ABC is equal to A dot B cross C, right? Absolute value.
So how do I know which one's A?
Good news. The cyclic property of the triple product says that this is equal to B dot C cross A, which is equal to C dot A cross B. So, in fact, I can actually erase the absolute values here, and that's actually an identity, the cyclic property of the triple product, which says that if I maintain the cyclic ordering of ABC, if I go basically just move A over and B, so it's always ABC, but you have to start ABC, ABC, ABC. Did I do it? Yeah, ABC. These are actually equal, but then I have to put a plus or minus over here, to be honest, because they'll either all be positive or all be negative, depending on whether ABC forms a right-handed triple or a left-handed triple, the more evil inferior version of triples.
So it doesn't matter which vector I assign to what when I'm
Nope. You'll find the same volume. Again, we have to take absolute value to allow for the evil inferior left-handed triples, but yes. I'm glad you all agree with me that left-handed people are evil. Yes? Oh, left-handed? Oh, okay. Are you saying you're without sin?
No, I'm saying.
Oh, okay, okay. Sorry, it's not a fair fight here, but no, my brother's left-handed, evil. What does it mean if you're ambidextrous? Then I don't know. Like, does it make you like an independent? I don't know. Yes.
Can you tell me that it's called form?
Yeah, sure. I mean, I hope. So here you're asked to find the parameterization of the tangent line to the given curve. So, how do you find the parameterization of a tangent line? Eventually, I'll remember to get the right thing. Oh, by the way, as ambiguous as it is the form of the equation here, the ambiguity in possible answers for the parameterization, it's far worse. There's so many choices. There's so many right answers for a parameterization question. If I leave it open-ended, I might say, makes it hard for me to grade, but see here. So basically the question is, you've got R of t is equal to some curve, here t squared, t sine t, 3. And I can say find the equation, find the parameterization of the tangent line at some point. You pick a point, whatever you want. What do you want? Say again? 62? Okay. Find parameterization. Now, why do I say find the parameterization of the tangent line? Why don't I say find the equation of the tangent line? I mean, I could do that, but that would be annoying. What would the equation of a tangent line be? You have to find the symmetric equations for the line, right? It would require 2 equations, basically each of those equations being a plane, and their line of intersection would be the tangent line. It's far easier to give a parametric description of it, and that's why I ask it this way, right? Because the parametric description of a line is by far the more natural one. So very simple. All I have to do is calculate r prime of t, which in this case is 2t sine t plus t cosine t, and 0. Find my direction vector at the time of interest, which is 62 here, which gives me what? 124. Sine is 62, plus 62 times the cosine is 62. 0. That's my direction vector for the tangent line. And then so the equation, the parameterization of the tangent line I could do this. Just, let's see here. So it's r of 62 plus t times r prime of 62. I can do that. Again, I guess you could make it match up if you wanted to. I don't care though. 62 squared, comma, 62 times the sine of 62. 3 plus t times the 124 sine, I'm running out of room, 62 plus 62 cosine 62, 0. It's okay. I think we can still see it. Stupid whiteboard. Haha. And there it is. That's the parameterization. It puts the point of tangency at t equals to 0 in my current formulation. Okay. If you want to put the point of tangency at t equals to 62, simply replace this with t minus 62, and then the parameters would match up between the original curve and the line. Are there any? Do you see? I mean, okay, yeah.
On the test, are you going to pairs where you simplify or solve sine of 62 into whatever many degrees it is, or if we just leave it in that form?
Sine of 62 is a number that is fine. Yeah. Yep.
I noticed that the bottom page of this quiz was no solutions for it. Is that the reason, or?
Problem 11?
What? No, I mean like the end of the quiz. So, yeah, okay.
Oh, I think it's because that one was actually on the test. I want to see if people can actually do it without me showing them how to do it. Well, problem 21 actually was on the test. I just want to see if people would bother to finish my quiz. Oh, I'm sure I did something hideous behind those pieces of paper. It's not, you don't want to see it. It's something horrible, whatever it is. What's that?
Could you post the solutions to the last one?
They're on the test.
Oh,
I mean, one of them's on the test, and the other ones, no, I'm not. I mean, the other ones you can think about if you want, but what were the other ones? I mean, problem 16 actually is a good question. I mean, can you guys tell me what the, I mean, I think we've talked about it enough today. You might be able to just see it. What's the Cartesian equation? If I take x squared plus y squared, what do I get? I get sinh squared beta. If I take, oh, this is supposed to be beta. Oh, this is not pleasant. That's a typo. That's supposed to be beta. Otherwise, this is really nasty. Like, really nasty. That is supposed to be a beta. If that's a beta, then you can see that z squared minus x squared minus y squared is equal to 1. So it's like a hyperboloid of 1 or 2 sheets, I forget. It's the one we didn't work earlier. The one we worked earlier had 1 minus. This has 2 minuses. Again, this should be cosh beta to make it interesting. Or you can leave it as t, and I'd have to really think about it then. That begs the question, how do you relate cosine t, sine t to cosh t? I mean, I can, but it's not as easy as like cosine. We're leaving the nice world of cosine squared plus sine squared equal to 1 and cosh squared minus sin squared equal to 1 for much more complicated things. I mean, fine, I'll scratch that itch for a second here. How does cosine x and cosh x relate? What equation relates these two? On an appropriate domain, you can do silly things like cosine of x is equal to cosh of cosh inverse of cosine of x. There's always that move. But there are formulas for inverse hyperbolic functions in terms of natural logs of appropriate algebraic functions, so it's not a vacuous comment. It's just unpleasant. So anyway, you need that kind of technology to unravel the problem as it's currently written. That wouldn't be a nice test question. It would be. I think I like you guys more than to ask that question. Yeah. That's a problem for Mathematica, not for a test. Yeah. Okay. Again, if I replace this with a beta, it's not a bad question. Other questions? Yes, sir.
Can they analyze the numbers that we have supposing that the vector A cross, down the vector B equals 0, so for all B. I want you to show that the vectors of A and B are orthogonal, basically perpendicular.
Mm-hmm. Well, this begs a larger family of questions, which is cancellation properties for. I mean, what is true about? Can you cancel dot products, right? I mean, it's like if I have A dot B. I mean, there's variations on this question. Suppose there exists B and C such that A dot B is equal to A dot C, right? Or assuming it's the other way around. There exists an A such that A dot B is equal to B dot C. Does it follow that B is equal to C? Very similar question. Suppose for all A, we have A dot B is equal to A dot C. Does it follow that B is equal to C? The difference between these two things is that one, I'm giving you a single A, which the dot product happens to be equal. And the second one is I'm telling you it's inescapable. If you take the dot product of A with B and A with C, they're equal, and that's true for all possible A. They're really different statements, right? And so you say the first one's false. Can you give me an example?
A equals 0, like 0, 0, 0.
Right, so if A is equal to 0, that is true, then 0 dot B is equal to 0 is equal to 0 dot C, and that it's, I mean, you can let B and C be whatever you want, and that's true. What if A is not 0? What if I throw in for free? Okay, A is non-zero, fine, that was too easy. Suppose A is non-zero. Is it true then? It is not. Because, of course, you can have things like, let's see here, how about this? 1, 0, 0, dot 0, 1, 0. That's equal to 1, 0, 0, dot 0, 0, 1. So here's my A, right? Here's B. Here's B. As you can see, it's 0, right? Both sides are 0. And yet, certainly B is not equal to C.
Well, B is not equal to B in this case.
Oh. Sorry.
B1, B2.
There you go. I shouldn't try to think and write at the same time. So no, one is false for many reasons. But why is 2 true? 2 is true because if you can do this for all A, in particular, you can select A equals to X hat, Y hat, and Z hat one at a time. And this then becomes the equation BX is equal to CX. You know, by is equal to cy, and bz is equal to cz. The components match by taking dot products with the unit vectors. If I can take the dot products with all unit vectors, of course they're equal. So yeah. So there's a big difference between for all and there exists, right? Similar comments apply if you have A cross B is equal to, A cross C. Can you then assume that B is equal to C? No, right? Very similar. But on the other hand, if you have the cross product with all three, it's enough. Actually, I think if you have A cross B and maybe if you have A dot B is equal to A dot C, if I have another condition maybe on A, that might be enough.
You can still do it with A equals 0.
Yeah, let's suppose A is not 0. Does this imply that B is equal to C? I don't know. Maybe. At least there's enough equations there, right? B equals to C is 3 equations because you need the x component, the y component, and the z component if we're talking about 3 dimensions. I mean, if I've got a cross product, the minute I write a cross product, I'm either talking about 3 dimensions or 2 dimensions inside 3 dimensions. But usually I'm talking about 3 dimensions. So in order to have B is equal to C, I need 3 things matching up. That's why you know at the start that's hopeless, because this is one equation to match up 3 components. So you shouldn't expect that to work, right? This is infinitely many equations to get 3 equations. That's pretty hopeful. I think that's true. How would you prove it?
Work it out with some Fisher notation.
Other questions? You guys know how to find the Frenet frame for a given parameterized curve? It's annoying, but it's straightforward, right? I mean, where's that stupid thing gone to? Oh, I think I freed them of the awfulness of it on the quiz, and I just did it on the test, right? Is that right? I mean, I warned them that was going to happen, I'm pretty sure. So you calculate the speed, calculate the arc length, and then you can either find the arc length parameterization and calculate from there, or you can use the modified Frenet array to find curvature and stuff in terms of the non-unit speed. So it's kind of up to you, but anyway, so you can look at that. It's pretty. This is almost exactly the example I worked the first day we talked about it, But oh, wait a minute. No, it's not. What am I talking about? This is something else. As I look at this curve, I notice that y squared plus z squared is going to give me 25 cosine squared. But if I look at x squared, I get 25 sine squared. So 25 sine squared plus 25 cosine squared is 25. In other words, x squared plus y squared plus z squared is equal to 25. This is on a sphere. This is a curve on a sphere. I think it's a circle. Is it a circle? Torsion 0. Woohoo! I mean, that means it's on a plane. And the intersection of the plane and the sphere is a circle. As you can see from the fact that the curvature is constant earlier. Yeah. Well, the torsion being 0 is what allowed me to be sure it was I mean, the fact that the curvature is constant showed me it's a circle, actually. But the torsion being 0 is just icing on the cake, because you can think about the circle being formed by the intersection of the plane in which the curve lies and the sphere. So, I mean, I can either see the circle again from the constant curvature or from the fact that it's the intersection of the plane and the sphere. I don't know. Or I could just, from the fact that x squared plus y squared equals plus z squared is equal to 25. That showed me it's, well, that just shows it's a curve on the sphere. It doesn't immediately show it's a circle per se. But
So if the curvature is constant, we get a torsion value less than 0, we should probably go back and check the work.
yeah, I'm just what I'm trying to get at is I could have there are curves on the sphere, right, that look like that, and those will not have, you know, vanishing torsion, and they will not have constant curvature. They'll be other. They also will not have nice formulas like the one I gave on this problem. Yes, sir.
Can you go through mission 1 number 10?
Mission 1, number 10. I would be happy to look at that. Let me see here. I hope if you look back at the test from last year, you can see it's not really that hard, but you need to know what you're doing, right? You need to have a clear plan in mind. Okay, this is he's asking me about blah, therefore I should do blah. You know, I mean, there's not a lot of time there's not a lot of time for introspection. Let's say I don't know. I don't deny you that. I mean, if you want to think about your life in my test, you're free to, but it's probably better to think about my problems. Problem number 10. Ah, yes. I like this problem. So, what is your question about problem 10? I lost track of who asked me. Yes, sir.
I don't know how you went from the first step to the second one. The BC marks you
Oh, there's a circle of cross products. So if I have x hat, y hat, and I have z hat, then you can figure out the cross products of these basic ones by looking at the circle. For example, this tells me that x hat cross y hat is z hat. So to get from the second line to the third line, I distributed, for example, z hat cross x hat. So z hat cross x hat gives me y hat. This is just a mnemonic to remember the formula for the cross product as it applies to the Cartesian unit vectors. But y hat cross x hat. See, there I have to go against the grain, so I get a minus z hat. Now, I hope, having said all this, I don't have a typo in my solution. It's always embarrassing. So z hat cross y hat, x hat gives me the y hat and the b, and y hat cross x hat gives me minus z hat, but then the minus cancels and gives me a plus. So, yeah. It's a very interesting formula, this thing. I'm quite certain that I have not fully exploited its usefulness yet in my life. I'm not saying it's necessarily on your test. It's not some kind of like veiled threat or something. I'm just saying I recently used an advanced calculus to solve a problem that I had not solved in the way I did before. I mean, I've been aware of this since about last year, but it's an interesting identity. Yes?
Also, do you want to be notified if you made a typo on the solution?
Sure, yeah. I mean, somebody has suggested that, what was it, problem, one of my angles might be wrong. Which one was that, guys? Was that in the mission 2 solution, was it?
It was number 5.
Mission 2, is it mission 1, number 5? So you're saying you didn't get 18.3 degrees? You got something else?
That is equal to cosine negative 1, 2 plus 1 half by 30. That whole thing is equal to.
Oh, you don't think the 855 over 900.56 is wrong? Oh man, left my calculator somewhere else. Well, I don't know. it's kind of intimidating. I haven't used one of these in a while. I'll try. Ah, not times plus. No, not enter. Yar. Oh, 851. Yep, 851, that's it. No, not plot. Ah! Curses. Quit. I'm hopeful that at least the denominator 900.56 was right. I get 19.096, or let's say 19.1 degrees. Very good. Yes, so problem 5, it should have had 19.1 degrees for beta because I made a, oh, come on. How'd that happen? What's going on here? When did that happen? Just now?
Like you started to turn that projector and interest, but
That is not cool. I hope it, well, I mean, I hope it has no significance in terms of the turning of the hour. It'd be weird. Come on. You won't even let me change modes now. It's dead. But yeah, 19.1. So that was mission 1, number 5. I had 855 where I should have had 851. That was the reason for it. But guys, just, focus on the basics. I mean, by now you either know it or you don't, but make sure you're rested. Do your best. And you do get a 3x5 inch note card, right? So, yes, sir.
where do you find the answers to the missions for this year?
They're in course content. They're in the Blackboard under the missions folder. I have not posted them on the website. Wrong. Yar. Oh, he's adding the